When finding a p-value for a population mean hypothesis test, essentially you're finding the area in the extreme tail or tails. For a left-tailed test, you're finding the area from negative infinity up to the negative t test value in the left tail, or from the right t test value up to positive infinity for a right-tailed test. Here I'm going to show you how to find the area to the left in the left part of the tail of a t-distribution curve. So first of all, just to find that area, you can use the distribution key for T cumulative distribution function, option 6. You push second vars to get to the distribution function. You can either go down to option 6 and press enter, and you'll be asked to enter in the closest number to negative infinity our calculator can do is -1 times 10 to the 99th power. And then the upper bound I'm going to show is negative 1.1916. And the degrees of freedom here are 8 because the sample size was 9. I paste that, it will enter all the values in the proper order and give me that area. Now for you to get a visual. From advanced statistics, you can find that the t-distribution function can be graphed by using a special function called the gamma function. And I have done some research and have that appropriate t-distribution function here in y sub 9. I've also written a program so that if I push alpha t, and you'll see the very first program that's unarchived is t-distribution. So in program t-distribution, it reminds me that it's going to graph the t-Gossett distribution and warns me that it will clear variables a and b. I'm going to push a and b, and remember there is a unique t-distribution for each sample size. And for a sample size of 9, the degrees of freedom is 8. So I've done that, and it simply says it's done. And I have to go to the graph to see the graph of that t-distribution. So this is the appropriate t-distribution. Now, using more advanced mathematics, i.e. calculus, I can use the integral command for a definite integral in option 7, and I'm going to use a lower limit, and I can only put limits in the screen window, and on the window, the x-min value is -6. So I'm going to put a lower bound for the integral of -6 and go up to the upper bound of -1.916, which was the problem I was just doing in the t cumulative distribution function. And you'll see that it not only computes the area, which is the same 0.046 to the closest thousandth that was computed with the TCDF function, but it also shades that area in that tail. So that's the p-value for this particular test. And you can see if I put second entry, this is related to what I did 2 calculations ago with the TCDF function, verifying the same area to the closest thousandth of 0.0